Alright, so the next lab we have is for Goal 5. It is the Covalent compound lab. We're actually going to compare 6 different compounds. And if you would please, right here, we have them already set up on the aluminum foil. They are all arranged. Because one of the first things you have to do in the lab is describe what they look like. Now, of course, everybody always says, Ms. Otry, they're all white. Yes, you are very observant. They are all white. But they have different textures. And right here we have sucrose. Right here we have phenyl salicylate. This is the calcium chloride. Back here in the corner we have potassium iodide. This is sodium chloride. And this is citric acid. So the first thing we're going to do is actually check and see their melting points, but we're not going to determine it by temperature. We're going to determine it by how quickly it melts and if it will melt. So I've already got my Bunsen burner lit because I didn't want that on tape. And what I'm going to do is go ahead and put it right underneath my setup here, and we're going to watch and see what happens. And we really want to make sure we know which one is going to melt first. And we already see some melting action right here. That's the phenyl salicylate. That is melting first. So you would want to put a 1 in that column. Ooh. Goopy goopy. Okay. That was fun. Something else melt now. Come on. Melt. Melt. Yep. Yep. Yeah, no exciting fire. Nothing catches on fire. At least it shouldn't catch on fire. And if it did, I'm wearing my goggles. Right. Safety first. Uh-huh. Yeah. Any good jokes lately? Since nothing's melting yet.
No, I should probably be wearing goggles in case something starts on fire.
Might be a good idea.
I don't think that was proper English.
It wasn't proper English.
Something does start on fire.
So
Sorry
something does
for
start. Oh, I saw it
people.
pop. Wait. Something's happening with the sucrose. It's changing colors.
Where is this?
Right over here. You really can't see it as well yet. Let's see. Come on, sucrose. Do something. We're actually giving this a time limit of about 2 minutes. So, oh, right here. Right there. You see that one?
Yes.
Bubbling. That is the citric acid. So the citric acid is getting some meltage here. Bubble, bubble. Still nothing from the other groups. We're supposed to give a 2-minute time. I do see a color change in that sucrose. It's going to a brownish color.
Could you move the Bunsen burner around, or is that bad if you do that?
Well, I'm trying to keep it on even heats.
It is melting, this one right here.
There your sucrose is going now. That one's like a little blob. So the sucrose would be number 3. So the first one to melt was the phenyl salicylate. The second to melt was citric acid, which is now just boiling like crazy. And we get nice vapor off of that. And the sucrose is now melted.
Should I be sniffing this?
We always waft in chemistry. We don't
Okay.
sniff or inhale. Yeah. But nothing yet out of the other 3. And it's probably been about 2 minutes. Hi there, Nick.
Hi.
Say hi, Nick.
What is up with the color
What's that?
change? Is it burning or something?
Well, it's getting hot. It's been 2 minutes, Nick?
Oh yeah,
It's been 2 minutes. I'm going to call it and say that part is done. And the gas is actually by you, so. But there you go. So we have the melting points and some great vapor going on there from the 6 compounds. That's part 1. Okay, so we're going to test solubility next. We're going to see if they are soluble or will dissolve in water. So I have all 6 of them labeled and put into evaporating dishes. So what I'm going to do really easily, they just tell you in the lab just to add water to it. Now again, in our classroom we use the microscale wells. Too small, won't work for us. So we're going to go ahead and just add water. I have distilled water in here. So this is with sugar. or sorry, that's sucrose, give the real name. There's citric acid. Okay, watch out. Those of you in the cheap seats. Phenolsalicylate. Sodium chloride. Calcium chloride. And potassium iodide. Look at that. Alright, so you can kind of look around and see which ones dissolve in water. And you can look and see, I definitely would say that the potassium iodide dissolved in water. Calcium chloride is also gone. Sodium chloride dissolved. The phenolsalicylate is kind of just floating on top. Citric acid looks like, well, I don't know. There's some on the bottom. I don't know if you can see that in the camera. So I don't know, it's somewhat soluble, I would say. Slightly. The sugar is what's making me, or the sucrose, this should all dissolve. But, let's see if I shake it. Shaky, shaky, shaky. Wiggles. You know, when you have little kids, you watch the Wiggles. No? Okay. Okay, well, you know. Fruit salad. Yummy, yummy. Oh, you know that one, Nick, huh? You gonna join in with me?
No.
Aw. But you can see after actually swirling it around, the sucrose did dissolve. Okay? So that's a solubility in water. So we're going to do a conductivity test very quickly. See if these will conduct electricity. They're still dissolved in water. So all my meters are on. We're going to see if the lights turn on. 2 lights, good conductivity. 1 light, not so good. So let's see. Well, sucrose, we got a dim red light, so that's not really a good conductor. Okay. Next one is citric acid. We'll see if that one conducts. Another, it looks like a dim red light. So it's not a good conductor. It's a poor conductor. The phenolsalicylate, which never dissolved. A dim red light again, poor conductor. Alright, then sodium chloride, which if you remember anything, that was the bell. If you remember anything, you'll know that this should, oh look at that, 2 nice red light and a green light. It's a conductor, strong conductor, sodium chloride. Alright, really quick. There's calcium chloride, again, 2 strong lights, good conductor. And then the last one here is potassium iodide, strong conductor, 2 lights. Okay, so that's conductivity. And we're going to do the solubility of all 6 compounds in ethanol. You ready, Nick?
Yep.
I think I'm going to start with you. I usually start, but this time you're going to start.
With what?
Potassium iodide.
Oh, got it.
Right now we have ethanol in all of the evaporating dishes. So we're just a little bit, not too much, because we want to see if it's going to dissolve in the ethanol. That's what we're looking for.
Should I stir it?
We can come back to it. Right now it's not doing much of anything. Okay, that's potassium iodide.
Oh, calcium chloride.
Mm-hmm. While you add, I think I might stir a little bit and see if anything happens to it. Of course, I might go ahead and spill ethanol all over myself. That'd be bad too. Okay, there's the calcium chloride. Again, not much going on in the ethanol.
Alright, there's the sodium chloride.
Ooh, Nick getting all technical now. Sodium chloride. Go,
Oh,
Nick.
yeah. More or leave it?
You know what? That should have dissolved, because if you know how if you add salt to water right away, especially to that amount of water, salt would have dissolved right away. And you can tell with that amount of salt, sodium chloride, and ethanol, it's still there. I don't think any of these so far are dissolving. be really bad and use my thing what they are. Use my spatula. Yeah, I don't think anything there is helping out. They're all still sitting on the bottom. Insoluble, it looks like, in sodium chloride. I mean, excuse me, in ethanol. Oh, Nick, go add the other ones too. Such a good job. It's more fun when you help, Nick. Isn't it, Mrs. Saget? Miss Saget, I'll get you married. Alright, so this is the phenyl salicylate.
Right, that stuff.
That stuff, the PS. PS. Phenyl salicylate.
And the citric acid.
Do you know what citric acid is in?
Huh?
Do you know what citric acid is in? Come on, smart guy. Come on.
Yeah.
What would you say? I didn't hear what you said.
Orange juice.
Orange juice.
Yeah, look at you being
Citric
all smart.
stuff. Good job. Look at that. Yeah.
Then sucrose or sugar.
Right. All right. So let's do a little stirring and see what happens here. Oh, now, if you remember from when we put the phenyl salicylate in water, it would have nothing to do with it. It floated on top. This one, it looks like it's taking its time, but it definitely looks like it's dissolving. Get a closer look at that. That's definitely less than what Nick had put in the beginning. This is citric acid. Gotta stir it up a little bit. It's like making tea, right? I can warm up the ethanol, but that would be bad. It would be flames, right? So let's not do that. So citric acid, when we stir it up, it looks like it's dissolving too. Would you agree, Miss Saget?
Sure.
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 Sure. All right, and here's the sucrose. Doo-doo-doo. Sweet ethanol.
You can go ahead and try it.
I'm not.
On your own.
You know, that's not my style. I don't know. That one I'm not convinced.
I don't think so.
Yeah.
Oops.
Not so
Nick, not so much, right?
Nope.
No.
dissolved.
Yeah. This one
Not
is
so dissolved.
not so dissolved. You can see it's still kind of coming there. Here, go pan load the other ones really quick. I'm going to see if anything else happens. But you can definitely tell a difference. Yeah, that's dissolved. The citric acid is dissolved. The phenyl salicylate definitely dissolved. Sodium chloride did not. And it would have if it would have. But it did not. Calcium chloride, no, not really. You can see it down there. The potassium iodide also down there at the bottom did not dissolve. And it looks like sucrose is a dud as well. So that is it for the Covalent Compound Lab. You have all the data you need. Make sure you fill out the table completely and answer the questions.
Right.
Wait.